The image arrived like a whisper across the cosmos, a single frame from the James Webb Space Telescope. It was a moment that felt both ordinary and extraordinary, as if the universe itself had paused to send us a message. Scientists and astronomers around the world held their breath, knowing that this was no ordinary photograph. On the screen, an exoplanet, impossibly far away, its atmosphere revealed in a spectrum of light. The colors and patterns told a story billions of years in the making, hinting at secrets hidden beneath swirling clouds and alien skies. Most of the data was expected, matching models and predictions. But then, a subtle, out-of-place chemical spike appeared, a blip that defied easy explanation. It was the kind of anomaly that makes scientists sit up straighter, hearts pounding with anticipation. A molecule almost exclusively linked with life on Earth appeared in the data. Its presence was like a fingerprint, delicate yet unmistakable, raising questions that echoed through every laboratory and research center. Scientists everywhere leaned in, searching for any natural explanation. Was it a fluke, a misreading, or something more profound? The world of science buzzed with excitement and skepticism in equal measure. Was it geology, chemistry, or something more, life itself? Every possibility was considered, every theory tested, as experts debated late into the night, determined to uncover the truth behind the signal. This wasn't a flying saucer or a radio signal, but a clue in the language of chemistry. It was subtle, almost poetic, a message written in molecules, waiting to be deciphered by those who knew how to listen. The news spread quietly, the data unverified but electrifying. Emails pinged across continents and hushed conversations filled the halls of universities and observatories. The world waited, holding its breath for confirmation. For the first time, we had a piece of evidence that suggested we might not be alone. It was a moment that would inspire hope, debate, and wonder. A turning point in our search for cosmic company. The search for life had become a tangible, data-driven scientific endeavor, fueled by curiosity and the relentless human desire to understand our place in the universe. My first reaction was a mix of intrigue and caution. I made it clear this wasn't proof of extraterrestrial life. The molecule, dimethyl sulfide, on exoplanet K218b is intriguing, not definitive. On Earth, it's produced by life, but alien worlds could create it through unknown processes. The excitement isn't we've found aliens, but we have a new chemical mystery. Science is about eliminating possibilities, not jumping to the conclusions. Public imagination drives progress, but we must be precise about what the data shows. The real achievement, we can now analyze the atmospheres of distant worlds. The next step is to investigate every possible explanation, biological or not. Extraordinary claims require extraordinary evidence. Discovering life beyond Earth would change everything, so skepticism is essential. We must exhaust every non-biological explanation before considering life. Announcing alien life prematurely could damage trust in science. Past mistakes, like the faster-than-light neutrinos, remind us to be thorough. We need robust models of K218b's geology and chemistry. Could unknown reactions mimic life's signature? We must find out. Each new observation will build or break the biological hypothesis. Caution isn't about stifling wonder, it's about ensuring discoveries are real. The thrill of science lies in the rigorous search for truth. There's a crucial difference between microbial life and intelligent life. While both are fascinating, they represent vastly different levels of complexity and rarity in the universe. Microbial life refers to simple, single-celled organisms, tiny, resilient, and able to thrive in extreme environments. Intelligent life, on the other hand, involves advanced cognition, technology, and the ability to ask questions about the cosmos itself. Microbial life is likely common. The universe is rich in life's ingredients. Organic molecules, water, and energy sources are scattered throughout galaxies, making the basic building blocks of life widespread. Planets with water and basic elements are everywhere. Astronomers have already identified thousands of exoplanets, many of which show signs of having the right conditions for life as we know it. Finding chemical byproducts of life, like dimethyl sulfide, is JWST's main goal. By analyzing the atmospheres of distant worlds, scientists hope to spot these telltale biosignatures that could indicate living organisms. Such a discovery would prove life isn't unique to Earth. It would be a profound moment, showing that biology can emerge wherever the right conditions exist, and that Earth is not alone in nurturing life. Intelligent life, though, is another matter. It requires not just the spark of biology, but a long chain of evolutionary leaps, chance events, and environmental stability. On Earth, it took billions of years and many chance events for intelligence to arise. From the first microbes to complex animals and finally to humans, the journey was anything but straightforward. The leap from microbes to civilizations may be incredibly rare. Civilizations capable of technology and communication might be the exception, not the rule in the cosmos. SETI searches for signals, but we may only find microbial life soon. Our instruments are tuned to detect the faintest whispers from distant worlds, yet so far silence prevails. The two searches, biosignatures and radio signals, complement each other. Together, they expand our chances of finding life, whether it's simple or advanced, and help us understand our place in the universe. Microbial life is the more likely near-term discovery, but even the smallest microbe found beyond Earth would change our understanding of life's potential and open new chapters in the story of the cosmos. For decades, we've listened for signals from other civilizations and heard only silence. Our most sensitive instruments scan the heavens, hoping for a whisper from the stars, but the universe remains quiet. This silence is both haunting and profound, forcing us to confront the possibility that we might truly be alone, or that intelligent life is far rarer than we ever imagined. This is the Fermi paradox. If life is common, where is everyone? With billions of stars and even more planets, the absence of evidence is a puzzle that challenges our understanding of life's place in the cosmos. The Great Filter theory suggests a barrier prevents life from advancing. Somewhere along the path from simple chemistry to interstellar civilization, something stops most life forms from progressing further. Maybe the filter is the origin of life itself, an event so improbable it's only happened once. Or perhaps it's the leap to intelligence, a rare evolutionary accident that set us apart from all other creatures. If we find microbes elsewhere, it means life's start isn't the filter. Life could be common, sprouting wherever conditions are right, even in the most unlikely corners of the universe. But the silence from intelligent life would be even more mysterious. It would suggest that while life may begin easily, intelligence and technology are much harder to achieve or survive. Perhaps the universe is full of microbes, but few thinkers. Countless worlds may teem with simple organisms, but never evolve minds capable of asking the big questions. Or maybe the filter is ahead. Civilizations may destroy themselves before they can reach out to the stars. Our own future could hinge on the choices we make in the coming centuries. The search for life is also a search for our own future. Each discovery, or lack thereof, is a clue about what lies ahead for humanity and whether we are destined to thrive or vanish. Each discovery, or lack thereof, teaches us about our place in the cosmos. As we look outward, we also look inward, seeking to understand not just the universe but ourselves and our fragile existence within it. My view is one of optimistic realism. The possible biosignature on K218b is a thrilling start, not a conclusion. We must follow the evidence, even if it leads to mundane answers. Simple life is likely widespread. The universe seems built for it. Finding it would redefine our place in the cosmos. Intelligent life may be rare, the silence suggests as much. This makes our existence even more precious. The search for life is a reflection of our deepest questions. The JWST image is an invitation to keep exploring, questioning, and wondering.